Welcome to our channel. Today, we're diving into the fascinating world of gravity. It's what keeps your feet on the ground, literally, but as always, the universe is far weirder and more wonderful than you might think. Get ready to have your mind blown by these incredible facts. Okay, so first things first, we've all heard gravity described as a force, right? In reality, gravity is the curvature of space-time caused by mass and energy. Imagine a bowling ball on a trampoline. What happens? It curves towards the bowling ball, right? Massive objects like stars and planets warp the fabric of space-time around them. But we're just getting started. So, if gravity warps space-time and time is a part of space-time, then gravity must also warp time. And you know what? It does. This phenomenon is called time dilation. Here's the gist. Time passes slower in stronger gravitational fields. The closer you are to a massive object, the slower time ticks for you relative to someone farther away. Now, before you start planning a trip to a black hole to become a time traveler, this effect is very, very small in everyday life. But it's measurable. In fact, atomic clocks on Earth's surface tick slightly slower than clocks in orbit. So the next time you're late for an appointment, just blame it on gravity. I mean, it's technically true, right? We've all seen those cool videos of astronauts floating around in space, right? They make it look so effortless, so graceful. But what's actually going on there? Are they really weightless? Well, not exactly. Astronauts in orbit are still under Earth's gravity. Gravity at the ISS is only about 10% weaker than on the surface. They appear weightless because they're in constant free fall. They're falling towards Earth but moving so fast they keep missing it. It's like throwing a ball so hard it curves around the Earth. This microgravity lets them float and do cool science experiments. Chapter 4. Einstein was right. Again. The discovery of gravity waves. Okay, strap in, because this one is really cool. Back in 1916, Einstein predicted gravitational waves, ripples in space-time caused by massive objects. Then, in 2015 it happened. LIGO detected the first gravitational waves, from two black holes colliding over 1 billion light-years away, confirming Einstein's theory and opening a new window into the universe. Chapter 5. Black holes where gravity goes to party. Now let's talk about the ultimate cosmic monsters, black holes. These are regions of space-time where gravity is so intense, so extreme, that nothing, not even light, can escape their grasp. Black holes form when massive stars collapse at the end of their lives. All that mass gets squeezed into an incredibly small space, creating a gravitational singularity, a point of infinite density. The boundary around a black hole, beyond which nothing can return, is called the event horizon. Once you cross the event horizon, you're toast. You'll be stretched and squeezed by the intense gravity, eventually meeting your demise at the singularity. But hey, at least you'll go out with a bang, or rather a very, very long spaghettification. Chapter 6. Tides, the moon's gravitational tug-of-war. Have you ever wondered why we have tides on Earth? Well, you can thank gravity, specifically the moon's gravity, for that. The moon's gravitational pull is stronger on the side of Earth facing the moon and weaker on the opposite side. This difference in gravitational force creates a bulge of water on both sides of Earth, resulting in high tides. As Earth rotates, different locations experience these tidal bulges, causing the regular rise and fall of ocean levels. The sun also plays a role in tides, but its effect is weaker than the moon's because it's much farther away. So next time you're at the beach, take a moment to appreciate the cosmic dance between Earth, the moon, and the force of gravity. Chapter 7. Gravity, the ultimate space travel hack. Space travel is hard. I mean, it takes a lot of energy to escape Earth's gravity and even more to travel to other planets. But what if we could use gravity itself to our advantage? Well, it turns out we can. Spacecraft often use a technique called gravity assist, or a slingshot maneuver, to gain speed. Here's how it works. A spacecraft flies close to a planet, and the planet's gravity pulls on the spacecraft, increasing its speed and altering its trajectory. It's like stealing a little bit of the planet's momentum. This technique has been used to send spacecraft to the outer solar system and beyond, saving fuel and time. Gravity. It's not just a good idea, it's the law. Chapter 8. Gravity, the weakest link. Gravity is responsible for holding planets, stars, and galaxies together. It's the force that shapes the universe as we know it. But here's the thing, it's actually the weakest of the four fundamental forces of nature. That's right, the weakest. The other three forces, the electromagnetic force, the weak nuclear force, and the strong nuclear force, are all much stronger than gravity. Think about it. A tiny refrigerator magnet can defy the gravitational pull of the entire Earth. That's how weak gravity is compared to electromagnetism. So why does gravity seem so strong? It's because it acts over vast distances and it's always attractive. Every bit of matter in the universe attracts every other bit of matter, no matter how far apart they are. Chapter 9. From the Big Bang to Galaxies, Gravity's Cosmic Sculpting. Let's rewind the cosmic clock all the way back to the beginning, to the Big Bang. In the earliest moments of the universe, everything was incredibly hot, dense, and pretty much uniform. But then, gravity stepped in and started to sculpt the cosmos. Tiny fluctuations in the density of the early universe, amplified by gravity, caused matter to clump together. These clumps grew larger and larger, eventually forming stars, galaxies, and galaxy clusters. Gravity is the architect of the universe, the force that brought order out of chaos. It's amazing to think that the vast cosmic structures we observe today are all thanks to the subtle workings of gravity over billions of years. Chapter 10, Anti-Gravity, Science Fiction or Future Reality. Okay, let's venture into the realm of speculation for a moment. What about anti-gravity? Is it possible to create a device that can counteract the force of gravity? Well, the short answer is we don't know. Anti-gravity is a staple of science fiction, but it remains highly theoretical. There are some intriguing ideas out there like manipulating dark energy, a mysterious force that seems to be accelerating the expansion of the universe. But so far, these are just that, ideas. However, that doesn't mean we should give up on the dream of anti-gravity. After all, many scientific breakthroughs were once considered impossible. Who knows what the future holds? Thanks for watching. If you enjoyed learning about gravity, don't forget to like, subscribe, and hit the bell icon for more mind-blowing facts. See you next time, and remember, the universe is full of wonders waiting to be discovered, so keep looking up, keep asking questions, and never stop exploring the cosmos.